Alright, welcome to your video on the P chapter. We're going to start off with some formulas that you would have learned in previous classes. And these are all formulas that you can have with you when you take a quiz or a test. And so I'm not going to make you memorize these, but you will probably end up memorizing them as you work problems. And so I just want to make sure that you're aware that I'm okay if you use these formulas on a separate sheet of paper or on a note card or something to that effect. You can have these formulas by you whenever you take quizzes and tests. Okay, let's go ahead and jump into solving some problems here. So we're going to spend the first part of our time together today discussing linear functions and how to write the equations of lines. And so recall from Algebra 1 that we say that two lines are parallel if their slopes are equal. So I'm just going to write here if they have equal slopes. And so when you see that word parallel, we need to think same slope. Two lines are said to be perpendicular if they have negative reciprocal slopes. And so I'll give you an example of what I mean by that here in just a second. So negative reciprocal slopes would mean, for example, if you have one line that has a slope of negative 1/4, then the slope that's perpendicular to that line would be the opposite reciprocal, which would be positive 4/1, just as an example. So in example 1, we're going to find the distance and the midpoint for these two points, which are given in function notation. So f of negative 1 equals 4. Remember, that just means the point negative 1, 4. And f of 3 equals negative 2 just means the point 3, negative 2. And so if I want to find the distance between those 2 points, then that's going to equal to the square root of the difference in the x-coordinates. So if I start with 3 first, that would be 3 minus negative 1. And then I'm going to square that difference. And I'm going to add it to the difference in the y-coordinates, which would be negative 2, subtract 4, and then squared. This is going to equal then the square root of 3 minus negative 1, which is 4. Squared gives me 16. And negative 2 minus 4 is negative 6, and when I square that, I get 36. Adding those two numbers together is going to give me the square root of 52. And from there, we want to practice the skill of simplifying a radical. And so to simplify this radical, I am looking for the biggest perfect square that goes evenly into 52. So if you think about some of your perfect squares that are smaller than 52, you'd have 49. Well, that doesn't go in evenly to 52. The next highest one would be 36. That doesn't go in evenly to 52. You'd have 25, which doesn't go in evenly. 16, which doesn't go in evenly. 9 does not go in evenly. And 4 would be the only other perfect square that is smaller than 52, and that one does go in to 52 a total of 13 times. And so this becomes the square root of 4 times 13. And because that 4 is a perfect square, it can come out of the radical and become its square root. The square root of 4 is 2, and so we're going to put a 2 on the outside, and then 13 is not a perfect square, so it has to stay underneath. And so that's our answer for the distance between those 2 points. Now, to find the midpoint, we're again going to use the formula. Whoops, sorry about that. Let's use a pen and not a highlighter. So for the midpoint, this is going to be basically the average of the x and the y coordinates. So if you find the average of the x coordinates, you're going to add them together and then divide by 2. And then for the y coordinates, you're also going to add them together. So 4 plus negative 2 and divided by 2. And then just simplify. So negative 1 plus 3 is 2, divided by 2 is 1. And 4 plus negative 2 is also 2, divided by 2 also gives you 1. And so there is our midpoint of those 2 points, negative 1, 4, and 3, negative 2. Okay, on letter B, on example 2 here, we want to find the slope. Again, these points are given in function notation, so if that confuses you, then please feel free to write down those points in ordered pair form. And then to find the slope given 2 points, we're going to use the formula y2 minus y1 divided by x2 minus x1, and then just plug into that formula and simplify. So for the numerator, y2 is going to be -2, subtract y1, which is +2, and then divided by x2, which is 4, minus x1, which is -7. The numerator is going to simplify to -4, and then 4 minus -7 will equal to 11, which will give you a slope of -4 over 11. Okay, here on example 3, we want to write this equation in general form. So let's talk a second about what general form means. That's the form ax plus by is equal to c, where a is positive and neither a nor b are fractions, which means if we have fractions, we're going to have to eliminate those by multiplying. And we want to find the equation of the line that passes through these points, -3, 6, and 3, -2. Okay, so the first step is we have to find the slope of this line, and since we're given 2 points, we're going to use the exact same formula we just used on example 2. So I'm going to find the difference in my y-coordinates, -2 subtract 6, and divide by the difference in my x-coordinates, which is 3 subtract -3. The numerator is going to reduce to -8. The denominator is going to be +6. And when we reduce that, we're going to get -4 divided by 3. Now, whenever we write the equation of a line, even though it says general form here, we always have to start from point slope form, no matter what. So we're going to start from point slope form, and then we're going to transform our equation into looking like general form. So point slope form says y minus y1 is equal to m times x minus x1. And I'm just going to plug in to this formula, and it does not matter which point you use. You're given 2 points. Whichever one you use, you will end up with the same answer. So if I use this first point here to write into my equation, then that's going to say y minus 6 is equal to my slope, which was -4 thirds, multiplied by x minus my x-coordinate, which ends up being x plus 3. Okay, now for general form, we do not want fractions. And so what we're going to do is we're going to multiply this entire equation by the denominator of this fraction right here, which is 3. And so if I multiply that entire equation by 3, what I'm going to end up with is 3y minus 18 is equal to -4 multiplied by x plus 3. You're not going to multiply 3 by the parentheses because that would mean multiplying by 3 too many times. And so you're just going to multiply that coefficient in front of the parentheses, the slope, by 3. And when you do that, it causes the 3's to cancel. Okay, I'm now going to distribute my -4 here. And so writing over here, that's going to give me 3y minus 18 is equal to -4x subtract 12. And now I want all of my variables to be on the left and all of my constants to be on the right. So I'm going to move this -4x over. It's going to become a +4x when I do that, plus 3y. And then I'm also going to move my -18 to this side. It's going to combine with that -12. And so +18 and -12 is going to give me a right-hand side of 6. And so since I have this in ax plus by is equal to c form, and my a is positive, so my number in front of x is positive, and I don't have any fractions, that means that I am finished, and I call this my final answer right here. All right, on example 4, we also want to write our answer in general form, but remember, we're not going to start from general form. We're going to start from point slope form. And this time we are given a point that our line passes through, and we are told that our line is parallel, which remember from earlier, we said that it has the same slope. Same slope as what? Well, the same slope as this line right here. And so how are we going to find the slope of that line? We're going to put this line into what's called slope-intercept form by solving for y. So that's the first step, is I'm going to find the slope by taking that equation, 2x minus 3y is equal to 7, and I'm going to transform this equation so that it says y equals. And so the first step is I'm going to subtract 2x on both sides. That's going to give me negative 2x plus 7, and then I'm going to divide everything by negative 3 to get y by itself, and so that's going to give me positive 2/3 x minus 7/3. And so you can see here that the slope of this line is 2/3. That means that the slope of the line that we want to write the equation for is also 2/3. Okay, so now step 2 is we're going to start from point slope form just like we did. So we use our given point here, negative 2, 2, and so y minus 2 is going to equal to 2/3 multiplied by x minus negative 2, which becomes x plus 2. Now, just like we did before, we want to get rid of the fractions, and so I'm going to multiply all of this by the denominator, which is 3. So I'm looking here to determine what I'm going to multiply by to get rid of the fraction. And when I do that, I'm going to multiply everything by 3. So this is going to be 3y subtract 6, which is going to equal to 2 multiplied by x plus 2. I'm then going to distribute my 2 into this parentheses, and so that gives me 3y minus 6 is equal to 2x plus 4. And now I need all of my variables on the left, which means I'm going to move my 2x to the other side, and I need my constants on the right-hand side, which means I'm going to move my 6 to the right. And so this is going to end up giving me negative 2x plus a 3y. When I move that negative 6 over, it becomes a positive 6. It combines with the 4 that's already there to give me a 10. And now I'm nearly finished, except for the fact that my a value is not positive. And so to make that positive, I need to multiply the equation through by negative 1, which basically just means that I'm going to change the signs of every term. And that is how I end up with the final answer right there. Okay, example 5 is similar to the previous two, except now we see that we want to write in general form, which again, we're not going to start from general form. We're going to start from point slope form, which is how we always begin, and then transform it to look like general form. We're given a point that our line passes through, and now we are told that our line is perpendicular to this line. And so remember, what does perpendicular mean? It means that we're going to take the opposite or the negative reciprocal of the slope given by this line, x plus 4y is equal to 8. So again, first step is to find the slope of the given equation. And so we're going to make this say y equals by first of all subtracting x from both sides, and then dividing everything by 4. And so that's going to give me negative 1/4 x plus 2, and so I see that the slope of this line is negative 1/4, and so what does that mean for the slope of the line that's perpendicular? Well, I'm going to take the negative reciprocal, so the opposite reciprocal is going to be positive 4/1, and so when I go to write this in point slope form, that's the slope that I'm going to use, positive 4. Okay, so using the given point right here, 3, negative 5, this is going to be y plus 5 is equal to 4 times x minus 3. And so now to get this in general form, the first step is to distribute my 4. And so I get y plus 5 is equal to 4x subtract 12. When I distribute, I want all of my variables on the left-hand side. So this 4x here is going to move to the left and become negative 4x plus y is equal to, now this positive 5 is going to move over and become a negative 5 and combine with that negative 12 to give me negative 17. And just like example 4, you notice here that this a value is not positive, and so to fix that, you're going to change the sign of everything in the equation so that we get 4x minus y is equal to 17.